Hello everybody, welcome to my YouTube channel. In this series of video, I'm gonna show you how to create this 3D animation. Basically what I did is capturing the motion from two different angles, front view and side view, and extract the 2D data by using OpenPose and reconstruct 3D data based on it. So actually I also used the Bicon system. As you can see, like hole markers on the whole body, and you can see like some cameras, the Bicon cameras around, but it's just like something extra I did for some research purpose. But in this video I'm gonna focus on how to make this basically. So to achieve the goal, there are mainly two pathways I have to go through. So first one is camera calibration, and the second one is the triangulation. So in this first video, I'm gonna focus on camera calibration, basically how to find intrinsic and extrinsic camera parameters, which will be used in the triangulation part. So triangulation, I can reconstruct 3D data from 2D data from OpenPose. So let's jump into camera calibration part. Okay, so for the camera calibration, I have to do some preparation first. So basically, what I did is to capture this checkerboard here from the front view. I think you get the point. I think this is enough. So this is the front view, and from the side view. Reason why I turned on the right is because later on I have to synchronize the time, or like starting point of the video, because we use the two different camera devices, and we turned on the camera asynchronously. So like I have to synchronize the camera, which I will show you in a second how to do it. So I think that's enough. So basically, after capturing the checkerboard, I slice the video into each frame like this, and just assign the number from 1 to like whatever in the end. So like I think like 1000 something, yeah. And just scroll down to find the frame the light is flashing on. So probably around this frame, 35, 36, or yeah, 35 probably. And do the same thing for the front view. So that was a side view, and this is the front view, and I just scroll down to skip some of the frames which I don't need. Where was it? Maybe like I skipped too much. So somewhere around here. Yeah, somewhere around here. Yeah. Then just create another file, and which is first frame is the one I just turned on the right. Okay, so this is the front view, and I did the same thing for the side view. So the first frame is the frame just I turned on the right. Okay, then in total there are 1135 frames in each view or each angle, which consists like 2270 frames. So the problem is, so eventually you have to bring all the frames into the Matlab environment, or like, yeah, Matlab application, and the Matlab has like certain limit of the data amount like which I can bring into. I think limit was like around 8 GB or 7 GB, I forgot. But like if you exceed the data amount, the application shuts down. So I have to select the frames which I can bring into. So I just randomly select the frames like from 116th to 620. So I did the same thing for the side. I can pick like any like frames as long as I match the number, because I already synchronized the time by using the flashing light, right? So I just bring the 500 frames in each angle. I mean about 500 from 116 to 620. Okay, and I just put all the frames into like one file like this. Then go to the Matlab and find the stereo camera calibration application. So if you don't have stereo camera calibration app, you can just add it from the add-ons and just install it, and you can just double click to open, and there is a tab here to add images. So just tap it and just browse to the file you prepared. So for the front, this file, I put all 500 frames and select folder here, and do the same thing for the side view. So go to the side 500, select folder like this, and choose the pattern. I think there are only two options, and I use the checkerboard, so I just select checkerboard, and you have to specify the size of checkerboard square. So in this square here, so I use the 30 millimeters like this, but you can specify like any metrics like here, and you just click OK, and the Matlab application automatically calibrates cameras for you. It takes time because I have like more than 1,000 frames together, and the Matlab has to work hard to do the camera calibrations. So basically, after you finish the camera calibration, you get the session you can save, and I already did it, so I will skip the camera calibration part and just import the calibration session here. Just open it. So basically this is a screen. It takes time to upload. Okay, so basically this is a screen you will see after the camera calibration, and of course you can save the session like this here, and you can use it later on basically. So the Matlab, so basically stereo camera calibration or calibrator app already removed some of the frames, or like the pair of the frames, one in the front, one in the side. The application already removed some of the pair or pairs because of the checkerboard detection. If it's failed, it's just removed from the camera calibration steps. So that's why the number doesn't start from 116th. So instead it starts from like 127, like this. Yeah, and skip some of the frames because it's already removed, right? So in each frame here, the app detects the checkerboard, and if I zoom in, you will see better. So basically just detect the checkerboard and find the 0 point and find the coordinate x and y, and basically detect the points on the corner between black tile and white tile. It's a little bit off, but you get the point here. Okay. Then there is a really interesting graph right here. So based on the checkerboard detection, the app calculated the extrinsic camera parameters, which is the relative position of two cameras. So one camera is this position and another camera is this position, and it's like a creepy object right here. It's the all positions of checkerboard right here. So this one is a little bit off. I don't know why. And there is another visualization, which is the camera centric or pattern centric, whatever it's called. Also, sorry, camera centric is another one here, and the pattern centric is the opposite one, like how the camera is seeing from this checkerboard. And the graph in the next is probably one of the most important things in the camera calibration steps. So basically it shows image pairs in x-axis and the mean error in the pixel in the y-axis. So this is so-called reprojection errors. So basically what it means is that each frame, for example, okay, let's use, okay, yeah, I can use this one. So let's say there is a 2D points in the frame. Point here, like a 0, point here, or like a yellow box point here. So this is ground truth point, and Matlab already calculated 3D points of 3D location of this point already, and reproject the 3D points back to the 2D points. And most of the time it's not exact point. The camera is calibrated really successfully, probably its exact location, but most of the time when you reproject the 3D point to the 2D point in the frame, there is errors somewhere right here, or here, or here, or there, and basically you can calculate the distance between the ground truth and the reprojection point. So that's the mean error in pixel. And as you can see, some of the pairs has a lot of errors like this, or here. So you can actually remove those pairs by reducing the threshold like this. So after removing the pairs, which has like a lot of errors, you can complete the camera calibration and you can export the camera parameters into the workspace. So after you finish the threshold stuff, you just come over here and export parameters to the workspace. Just click right here and specify the name and just click OK. Or if you want to export it, estimation errors, you can just click on it, but I don't need it, so just click OK. And if you go back to the workspace like Matlab, you can see the stereo parameters, and you can see the rotation, what translation of the cameras, and you can find the camera parameters. This is camera number 1. This is the intrinsic camera parameters, and I think this is the extrinsic camera parameters. I think this is relative to camera number 1 in 000 position, and you will see the rotation of camera number 2 and the translation of the camera number 2. And you can see the intrinsic camera parameters in the camera number 2 as well, like focal length, principal point, etc. etc. So that's it for this video, which I focus on camera calibration by using Matlab. So in the next video, I will show you how to use these camera parameters and how to reconstruct the 3D data from the 2D data from two different angles. Okay, so please subscribe my channels and see you next time. See you.